In this video I want to talk about global variables and why we typically avoid those. An identifier such as a variable name is in the global scope if it is not declared in a compound statement. Of course we have named compound statements such as functions, classes or namespaces. Now what is the scope of a global identifier? Well, it's basically from the declaration to the end of the file, but it is also global across files. And of course if you think about what that means for a second, let's have a variable x in one source file and another variable x in another source file, then you have an identifier conflict. We will learn more about this in the module C++ 102 and how to avoid those conflicts. You can think of the global scope as a global namespace. So when an identifier is in the global scope, then it is basically in a global namespace. Alright, let's have a bunch of people working in the company, and as these people work and generate files, they simply add all of the files to the same folder on the same server. What's going to happen when all of those employees in the company keep adding files to the same folder? Eventually you'll get a conflict, right? I can think of that single folder on the server that everyone keeps adding files to as the global namespace. And you want to avoid polluting that global namespace, right? You want to create subfolders instead and organize your things by using subfolders. And that is what namespaces allows us to do. And we'll talk about global namespaces in more detail in the module C++ 102. Local variables, in other words variables that are local to those functions, again including the parameters, are not global. Okay, they are not accessible to other functions. They are local to that particular function, so in other words they do not pollute, as it is referred to, the global namespace. That avoids conflicts. Next, let's look at a quick example in Visual Studio where I'll demonstrate why I typically avoid global variables. In this example I have a global variable right here, int x, which I initialize to 0. You can see it is declared outside of a code block. It's not within the square function and it's not within main, so it is declared in what is referred to as the global namespace or the global scope. Now within the main function I'm going to enter an integer to square, so I do cnx and then I do console output x squared is and then do square, alright. Then I do enter another integral to square, cnx, and then I do console output x squared is square again. At this point you can think, okay, this program is still in development, it's not quite complete yet. You may not have tested it all that much at this point, right? And you want to do something like this. The sum of the two integers is, and then I do x plus x. It depends on what you want to sum. This is just a quick example, but of course this program is not going to work because if you look at the square function, it uses that global variable x. Okay, we do cnx in the main function, and then in the square function we do x is equal to x times x, and then we return x. Square returns by type of int. Pull and run and see what I mean here. Enter an integer to square. I enter 3, press enter. We can already see the problem that we get. 9 squared is 9. That is incorrect. It should be 3 squared is 9. I enter 5, press enter. 25 squared is 25. Again, that should be 5 squared is 25. And then we get the sum of the two integers is 50, which is incorrect. What we want here is either 3 plus 5, alright, which is 8, or 25 plus 9. This is a typical thing that you'll run into as a beginner. How do I go and solve this issue? There's a quick exercise for you. Try and fix this program by using local variables and parameters instead of the global variable. And again, you can decide what you want to add or sum here at the final statement. Okay, go ahead and try that now. When we come back, I'll show you my solution. Alright, I'm back, so let's look at a few more examples here. What you could have done is something like that, right? For the square function, then it is simply going to return x times x, because one of the problems that you can see with the global variables, I'll just undo there, is that both functions, the square function and the main function, now has access to that variable x, and both of them make changes to that variable x. Here I do cnx, that changes x. Here I do cnx again, that changes x once more, and the square function also makes changes to x. One solution to that is we avoid making changes to it. So instead of assigning to x, I'm simply going to return x times x. This does not modify the variable x. Of course, you can do something like that to make it easier to read if you want. And now I can build a run, and 3 squared is 9, that is correct. 5 squared is 25, that is correct as well. Then we still have this problem of what we want to sum. That being said, I'm actually going to comment out the global variable and I'm going to use a local x instead. And I basically want to pass that value that we type in into this function. How do we do that? Well, we need a parameter in the square function. And so we can multiply those together and return the result. The parameter is local. It's basically a copy of the value x that we are going to pass in. So we're not actually making changes to the local variable x when we call that function. Here we have to pass in x now. X squared is, and we pass in x for the square function, and the same down here. And so on, you'll keep debugging this program to see if it works. So we enter 5, that seems to work fine. 3, that seems to work fine. Now it depends on what you want to do. The sum of the two integers is 6. That is not correct. We are going to have to introduce an additional local variable for that. I'll do sum right here. And then you can decide what you want to do. You can enter x in there, or you can enter the squared value. I'll do the sum variable and I'll add the squared value to that. And the same down here. Again, each time I'm simply going to add that value to the sum variable. Now we can do something like this. The sum of the two squared integers is, and I print out sum. Alright, build a run and see if that works. I'll enter 3 and 5. 3 squared is 9, that's fine. Enter another integer to square 5. 5 squared is 25. And the sum of the two squared integers is 34, which is correct. 9 plus 25 is 34. Okay, so this was just a quick example of why you would typically avoid using global variables. Now sometimes you can use constant global variables, because of course you cannot write to those, or in other words change those. But I prefer to avoid global variables altogether, whether those are constant or not. And then one final thing, I can do this right here. Cut that out and paste it right here. Maybe set that to some value such as 55. Before I do the cout and the cin statement, I want to just print out what that x variable is. So in other words, is it 0 because we have it declared using the list initialization style, or will we get 55? Pull the run to see what we get. And you will see we get 0, not 55. Basically, the local variable x hides the global variable x. Right, quite a few things I wanted to demonstrate to you in this simple example. I hope you found it useful. A quick recap, use local variables and parameters rather than global variables. That will prevent identifier conflicts and one function inadvertently changing the value of some global variable that is also used in other functions. Of course, in some cases you can use a constant global variable because you cannot modify the state, or in other words write to a constant variable. And sometimes we have more than one function that needs access to a specific variable or some value. Now in that case again we use parameters instead of global variables. That makes it clear to the reader what variables the particular function will operate on. Remember that you'll typically be working in a team, so it's important that your program is easy to read, easy to understand, and easy to debug. As we type in, IntelliSense gives us the formal parameter list, which basically indicates to us what arguments and what type of arguments that function accepts and will operate on. It also makes it easier for us to develop code that we can reuse in other programs. And you'll often be organizing related code in namespaces. So you'll be adding your classes and functions in your namespaces. Classes can also contain their own functions, so you can add functions in your classes. In this way you can wrap related functionality within classes or namespaces, and thus reduce the clutter in your global namespace. The lesson in this is to avoid identifier conflicts. Only functions, classes, and namespaces should be declared in the global scope. We will learn more about classes and namespaces in the module C++ 102 as I mentioned. As we've also seen, a named or unnamed code block hides outer variables that have the same names as those variables that are declared within the block. And of course, in general, you should try and avoid duplicate variable names. When program execution reaches the end of the code block, variables that are declared within the code block, which are called block variables, are destroyed and thus become inaccessible. That being said, global variables persist since they are not local to any code block. Local variables and global variables are actually stored in different memory segments that are used by our program. Local variables and function parameters, which are also basically local variables, are stored in a segment called the stack, and then global variables are stored in a memory segment called the static segment. We will discuss the memory segments used by our program in more detail in the module C++ 102, including the stack versus the heap. What the stack actually is like a stack of coins or a stack of books. Alright, so I'm only introducing this here out of interest so that you can see, okay, things are not quite as simple as they seem. The variables in our program are actually stored in different memory segments. Alright, that is going to wrap up this lecture. I hope you found it useful, and I'll see you next time.